right, on page 43 and 44 in your practice book, that was part of your homework last night, we are adding and subtracting numbers in scientific notation. Now you should have had this in your graphic organizer already, plus we went over it in the instruction book. There is a special requirement for when you're adding and subtracting, and that requirement is that the base 10s have to match before you can add or subtract anything. Now they gave you an example that they've worked through here. You're welcome to look through that. I recommend it actually. Number 1 says, in the example, 2.4 times 10 to the 6 was written as 24 times 10 to the 5th. Explain why those expressions are equivalent. The expressions are equivalent because it represents the same number in different forms. Okay, it's the same number, it's just different place values of that number. Instead of 2.4 times 10 to the 6th, they changed it to 24 times 10 to the 5th. Okay, they just multiplied 2.4 times 10 and subtracted one of those exponents. James rewrote the problem as 0.38 times 10 to the 6th plus 2.4 times 10 to the 6th, and then he added. Does this method work? Yes, it does work. Okay, he still made his base 10s match. He just adjusted up instead of adjusting down. And my explanation here is going to be that you can adjust either number as long as you do it correctly. Okay, you can adjust either number. You can go up or you can go down. Actually, I showed you yesterday that I like to go up. They like to go down. Number 3, you can use the same method to subtract numbers in scientific notation. Complete the steps to compare the subtraction expression 2.1 times 10 to the 9th minus 9.7 times 10 to the 7th. Now the problem with filling in someone else's work is that you have to do it their way. And they're going to do theirs like they did the example. So if you were struggling with this, you should have referred to the example to kind of walk you through. You've got 2.1 times 10 to the 9th minus 9.7 times 10 to the 7th. Notice that the 9.7 times 10 to the 7th is the same. They're wanting to adjust the 2.1. You're going to want to make the 9 go down 2 to a 7. We decrease the exponent by 2. We increase the constant by 2. So it would be 210 times 10 to the 7th minus 9.7 times 10 to the 7th. And then they're showing you the distributive property. Okay, this is the distributive property. And 210 minus 9.7. It should give you 200.3. Correct me if I'm wrong on that. Now, we have a number in scientific notation, but it is not in the correct form because our number is greater than 9. Okay, we've got 200. That needs to be one place value. So we're going to move our decimal 2 places, which is going to increase our exponent by 2. So 2.003 times 10 to the 9th would be your final answer. Number 4, evaluate the expressions 4.6 times 10 to the 9th plus 1.7 times 10 to the 7th. Now the first thing you should see is that the base 10s do not match. You have to fix that. I like to make my smaller exponent bigger. So I'm going to take 1.7 times 10 to the 7th. I want to increase from 7 to 9, which is plus 2 in my exponent. Now if I'm increasing 2 place values on my exponent, I'm going to decrease 2 place values on my constant. So 2 gives me 0.017 times 10 to the 9. Now I'm going to add, and I need you guys to remember that when you are adding these, you're going to add the constants and you're going to keep the base 10. So we're going to have 4.6 plus 0.17, which would be 4.617 times 10 to the 9th. We keep the base 10. Then you're going to check to see if it's in proper scientific notation. I should have one digit between 1 and 9 to the left of the decimal, and I should have a base 10, which I do. On B, I've got 5.4 times 10 to the 5th minus 1.4 times 10 to the 4th. I'm going to increase the 10 to the 4th by 1. So I'll have a plus 1. If I increase one place value on my exponent, I decrease one place value on my constant, giving me 0.14 times 10 to the 5th as my new number. 5.4 plus 0.14 is going to give me 5.54 times 10 to the 5th. Okay, guys, I just did the wrong operation here. Just like I told you, you need to always check your operation. I was subtracting. It should have been 5.4 minus 0.14. So I have to do a little borrowing. It's going to give me 5.26. 5.26 times 10 to the 5th. Now, if you adjusted down instead of up, you would have still got the same answer as long as you verify your scientific notation. Okay, you've got to make sure the scientific notation is correct. If it's not, you've got to fix it. On number 5, explain one way that you could check your answer to the problem in 4B. If I was going to check it, put it in standard form and subtract. You could check it in a calculator as well, but you're probably going to have to put it in standard form before you do that, unless you know how to use the scientific notation buttons. On number 6, find the perimeter of the rectangle in scientific notation. Now, perimeter is the distance around. It is one-dimensional. It's just how far we're going around something. So we just have to take all 4 sides and we have to add those up. Now I've got my book folded so you can't see that other side. 8.2 times 10 squared. Now, perimeter, I'm going to add the 2 short sides, 8.2 times 10 squared plus 8.2 times 10 squared. Okay, that's my 2 short sides. I also have to add my 2 long sides, 2.4 times 10 squared, or to the 3rd, sorry, plus 2.4 times 10 to the 3rd. Now, I didn't set those up like a traditional addition problem because I've got 2 base 10s that are squared and I have 2 base 10s that are cubed. I'm going to add the squared ones, then I'm going to add the cubed ones, and then I'm going to adjust, so I only have to adjust one time, and then I'll be done. So when I add here, I've got 8.2 and 8.2 makes 16.4, and then I keep the base 10 the same. And 2.4 and 2.4 makes 4.8 times 10 to the 3rd. Now I need to add these together, but I can't because my base 10s don't match. I have to fix those base 10s. You can fix either one. I'm going to increase my 2 to a 3 by adding one place value. If I add on the exponent, I have to decrease on the base 10. So I'm going to have 1.64 times 10 to the 3rd plus 4.8 times 10 to the 3rd. Now, just so you can see it a little cleaner, I'm going to restack this up. I'm going to move the 1.64 times 10 to the third below. And now I'll add. I've got 4, 8, 10, 14, and 6. 6.44 times 10 to the third. I will double check my scientific notation. I have one digit to the left of the decimal, so I'm in good shape. 6.44 times 10 to the third. Last question on this one. The area of the Southern Ocean is about 7.85 times 10 to the 6th square miles. The difference between the areas of the Indian Ocean and the Southern Ocean is about 1.865 times 10 to the 7th square miles. Explain how to find the area of the Indian Ocean and then find the area. We talked about one of these yesterday where you're still using a traditional formula, but they're kind of changing it up a little bit, so you're solving for something other than your traditional numbers. If you had, they're telling you difference, which means you've got a subtraction problem. The difference of the Southern Ocean and the Indian Ocean is 1.865 square miles. I'm not sure which one is bigger. So let's try Southern minus Indian equals the difference. Okay, Southern minus Indian equals the difference. Now, if I come up with a negative number, I'm going to know I've done that backwards and I need to switch it. The Southern Ocean is 7.85 times 10 to the 6th minus the Indian Ocean is equal to the difference of 1.865 times 10 to the 7th. Now, I am solving for the Indian Ocean. I am going to subtract the 7.85 from both sides. Which would leave me with a negative Indian Ocean and whatever the difference is. Now, I do have to adjust before I can subtract. So if I make the 6 become a 7, I add one exponent and I decrease one place value. So I would have 1.865 minus 0.785. And that gives me 1.08 times 10 to the 7th. Now, when I divide by this negative, it gives me a negative answer, which means I just did that completely backwards. I have to do it again. This should be, it should be Indian minus Southern. So the Indian Ocean minus the Southern Ocean is equal to the difference. Same process, I just had to change the formula because I didn't know which one was bigger. So if I did, Indian is my unknown, minus the Southern Ocean, 7.85 times 10 to the 6th, equals the difference, 1.865 times 10 to the 7th. Now, instead of subtracting, I need the opposite, which would be addition. So I'm going to add 7.85 times 10 to the 6th to both sides. Now, just like I did in the last problem, I still have to adjust this one exponent and make it 0.785. And then I've got 1.865 plus 0.785 gives me 2.65 times 10 to the 7th. And that is the size of the Indian Ocean. And that is the answer to that question.